Well, hello YouTube. My name's Mike DeConto. Let me introduce you to this new channel, Mastering AI Programming. Today we're going to talk about a new project I just started. You can go to on GitHub. It's called the XLM Echo API. It stands for Cross Language Model Ecosystem API. So today I just want to give you a short introduction to the project. Talk about the problem, what was the motivation for doing this project, give you a short demonstration, and then talk about next step, where I'm going to be going with the project. And if you are a developer, I hope you'll join me in the project. So let's begin with the target of the project. What is it about? It is about something called the large language model ecosystem. And actually, this will apply to large language models, small language models, and everything in between. That's why the name of the project is XLM for Cross Language Model. You see here a description of the LLM ecosystem, or XLM ecosystem. What does that mean? That is all the other technologies and services around the large language model. So you see the large language model here. We have things like RAG and prompt memory and guardrails and vector databases, embeddings, web search assistants, all these things around the large language model. And what we see here is an ever-increasing complexity and ever-increasing difficulty for developers to keep up. So that was the motivation behind creating this project. So if you go to GitHub, you'll see the key benefits that I'm trying to deliver with this project. Cross-language model, which means large language models, small language models, and everything in between. Cross-programming languages. A lot of these providers will have some programming languages, but not others. They kind of support their suite of what they think is their favorite or their most popular programming languages, but not all of them. And then, of course, we desperately need some standardized APIs that are well designed and intuitive to go across this ecosystem of AI operations. So, to get more details on what is this LLM ecosystem, I wrote an article. You can go to my site, deconta.us. You click on this article, and this will go through all the details of what do we mean, what are the basic services, and then it goes down through all of them. So what does it mean by embedding services or vector databases, RAG, prompt memory, etc. So this will describe that ecosystem. It doesn't describe the problems. In other words, how developers have to chase APIs that are poorly developed, APIs that don't support the programming language you want, etc. But that's left to this project, which I'm introducing today, called the XLM Echo API. So you can go to that article, understand the LLM ecosystem. Now, the other thing I want to talk briefly about is the architecture, and then I'll give you a demonstration of the software, or the initial implementation of the software. So as you can see here, it's a fairly simple architecture. It leverages something called gRPC. This is a Google technology, stands for Google Remote Procedure Call. It's basically a very easy way to create client-server applications across a network in a language-neutral way. And of course, that language-neutral way is really critical to design. There's really two key pieces to the design here. The first is language neutrality. As you can see, gRPC supports many languages: Java, C, Python, C#, Go, all the most favorite languages, Rust, etc. In fact, if you go to, you look up gRPC and you go to their website, you'll see how many languages they support, that they do indeed support a wide variety of languages. So you see all these languages are supported. And there's probably others by third parties, but these are the ones that this project currently supports. So you would want clients in all these languages. The other key aspect is, so you have your gRPC server. So we'll have clean interfaces for all the different ecosystem capabilities, the basics like chat, embedding, RAG, etc. And then your clients would be able to access those services by calling those remote methods. But then you have the provider architecture. You have providers, multiple providers. Obviously, you see the big three there. But you're going to have also, like for the very vibrant open source community, there's lots of other providers possible to target different LLM environments and different LLMs or SLMs in terms of including, of course, the open source models. So this basic architecture is what we are shooting for. Let me give you a quick demonstration of the code and then I'll talk about next steps. So the way the code is created, this server is packaged up into an executable jar file. So to run it, you just run the jar file. And that will have a configuration file, and that configuration file will tell it what port to run on, what providers are available, and the providers are pluggable, which means they can get loaded at runtime. New ones can get created by third parties. If you join the project, you can create your own provider plugin, and then they will be available to the environment. So the next part is you're going to have one or more clients. Now this is an example of the Java client. Right now I've created a Java client and a Python client to show the cross-language capabilities. So here's the Java client. So you specify what server it's going to connect to, what port it's going to connect on, who's the provider. In this case it's OpenAI, what model you want to run in that provider, and then what the prompt is. So when we run the client, a few things are happening here. The first thing is it's going to test out is some of the provider management methods. And then after that, you can see it created a synchronous chat, an asynchronous chat, and then an embedding. So those are the key functions that are supported right now in the server. You see the embedding is quite long. But you have the ability to manage providers like query providers and see what services they provide. You have both synchronous chat and asynchronous chat, and we will be making this much more sophisticated, as an example, adding like a conversation API. And then after that, of course, I also mentioned the embedding feature, how you need to be able to get an embedding, especially if you're going to do a RAG operation. RAG stands for Retrieval Augmented Generation. We'll talk more about that in a future video. So after that, the client gets unregistered, and that's the services supported by that client. And we could do the same thing with the Python client. Just go into the Python directory. There is a run client. There we go. There's a run client application, which basically sets the Python path and things like that. As you can see, very similar. So this is running Python right now. It created and and it mimics the operations in terms of test as the same as the Java client. There is a different prompt. It asks about SpaceX, but then everything else you can see is very similar. So here we have that cross-language capability. And right now there's both an OpenAI provider and a Google provider for the cross-language model capability. Okay, so last thing we wanted to talk about today, and again, you can go to the GitHub and look at the details of the project. These are the things we have for our architecture we just talked about. But then I want to briefly end this by talking about the future features of the project. So as you can see, we started out with the very basic things: synchronous completion and asynchronous completion. In other words, sending a prompt to the large language model and getting it back either synchronously, an answer either synchronously or asynchronously. Asynchronously being streaming. As each token is generated, or a set of tokens are generated, you get back that completion in a stream of tokens. But you could see there is a lot more work to be done. We need to add a conversation API. How are you going to store conversations for a user? That's very important, right? Because they may have multiple conversations, and they may have different types of conversations. Like they may be asking to generate an image, or ask queries, ask prompts about an image, image recognition, image generation. Those are very different things. You may have different types of completions coming back. You may have code, you may have just raw text, you may have formulas. How are you going to handle that? As you can see, all these things in the current environment is a problem, because you have all these vendors and they're all doing this stuff slightly differently. So developers are on a treadmill here, or a hamster wheel if you provide. I am going to write an article about this API crisis. This has occurred before in the web, in cloud computing, and it's occurring now in the generative AI space. So we hope to solve that problem with this project, or at least alleviate it slightly. Of course, there's various ways to customize large language models, personas, embeddings, RAG implementations. This is a very important one. Prompt memory, code generation, agents. There's all these various capabilities and lots of API design work that needs to be done. I hope this video has inspired you to possibly join this project. I would welcome your assistance, and I will be continuing these videos, continuing writing articles on this, to explain this and to push this forward. Anyway, I appreciate your time today. Have a great day.